All right, we'll just give it about 1 more minute and then we'll get started. Make sure everyone gets in from the waiting room. All right. Well, welcome everyone. Thank you for joining us. Welcome to the Circular Bioeconomy Systems Institute Member Hour Series. I am Alicia Mohnbach, your host for today's session. The Circular Bioeconomy Systems Institute, or CBSI, aims to transform the traditional take, make, use, dispose linear economy system into a more sustainable circular bioeconomy system that regenerates natural resources, reduces waste, and minimizes environmental impact. In this next installment in our CBSI Member Hour series, we have Dr. Sharvari Raut of Netzsch Grinding Dispersing, Germany, joining us to discuss opportunities and challenges associated with process optimization within the food industry as we move towards circularity in production. Before we kick things off, let's quickly go over some session ground rules. First, please keep your audio muted during the presentation. If you have questions, feel free to drop them in the chat. We will also open for verbal questions during the Q&A segment later in the session. And finally, this meeting is being recorded and will be available for later viewing on the ASABE website. So now, without further ado, let's introduce our speaker, Dr. Sharvari Raut. Dr. Raut is currently the Business Development Manager in the business food field at Netzsch Grinding and Dispersing, Germany. With an academic background in process engineering, she focuses on optimizing processes within the food industry. She is a guest researcher with the Leibniz Institute of Agricultural Engineering and Bioeconomy and actively supports the supervision of doctoral researchers. Since 2023, she is the co-lead of the Young Professionals workshop sponsored by the Circular Bioeconomy System Institute, as well as the chair of the Young Professionals Network of the European Society of Agriculture Engineers. So I'm excited to spend this hour learning more about how we are optimizing food processes as we move toward circularity in this industry. So please join me in welcoming Dr. Sharvari Raut.
Thank you so much, Alicia, for your kind welcome. And for all of you from my side, good afternoon as well as good evening from Europe. I am Dr. Sharvari Raut, and I'm going to be focusing today on the topic of processing our way towards circular bioeconomy. And before I move forward from my introduction slide, and as this is member hour, I would like to also apologize for using the older logos and to make sure for the next one to have the new logos into our system. So as I go ahead, I am going to be first giving you a short overview about what I'm going to be presenting in today's presentation. I will first give you a short background and introduction to what is our actual issue, what we have to look into, and then give a little bit more of facts and figures about the food and drink industry in Europe. This will then move on to a case study, or rather an example of how we have looked into the challenges and looked into optimization factors in the food drying process. The new methods that we are currently planning to implement are also implementing in this drying process. And then finally, give a future outlook, which will not only encompass a future outlook in the terms of processing, but also an outlook as to what we need to consider in terms of circular bioeconomy. So, starting with, we all know that the earth is in distress. And this comes around because of the high amount of greenhouse emissions, we have increasing global warming and increase in climate change as well. This is evident with the rising temperatures, with the unseasonal weather, as well as the different amount of changes that we are having in our ecosystem. In addition to the changes of global warming, as well as climate change, we have an increasing set of population and a decreasing set of natural resources. This in turn also means that we are unable to fulfill all the demands that are required for the population through our current natural resources. And therefore, we have to work towards making sure that these natural resources are also saved, and we can look for alternative resources that are more efficient as well as sustainable in nature. To that end, when it comes to food, food and nutrition security plays a larger and a bigger role. In a recent study that was conducted and the report that was published by Food and Agricultural Organization, the new numbers show that about 735 million people currently suffer from hunger, 3.1 billion people cannot afford healthy diets, and more than 7% have increased cost in healthy diets. One thing that we have learned post the pandemic era is that healthy diets and nutritional food supply is very eminent to ensure that there is no more hunger, there is a healthy lifestyle across the population, and that we can move forward in a much better way. Understanding the food insecurity that we have, the UN also gave in the Sustainable Development Goals. Now, the Sustainable Development Goals are well known to all of us. We know them as our SDGs. In this slide, the SDGs that I have presented to you are presented more in the form of the wedding cake model. Now, the wedding cake model was presented in 2016 at an EAT Food Forum conference. And in this conference, the speakers also mentioned that it is a new perspective of learning to see how these development goals actually interact with each other. They suggest that food is also one of the core factors that interlink between the three sections of the development goals that have been split in this model. So you have the biosphere section where you have four goals, then you have the society and the economy. And the wedding model, as you can see, wedding cake model, as you can see over here, is quite interactive. So let me give you an example. If you take the Sustainable Development Goal number 13, climate action, the changes that we need to make into climate to know what we can do, that we can work towards this goal, are very important and also interlinked to the society section, where zero hunger being the sustainable development goal being directly affected by, directly or rather indirectly being affected by the climate action goal. And this subsequently also affects the economy goal. So the understanding to this is that we do not have to only look at these goals on independent level, but to look at the interaction between each of them and work towards taking the interlink between each of these development goals. And when we talk with food being a core factor of it, in Europe or in anywhere else, of course, the food and beverage industry plays a vital role. In the European Union, the food and beverage industry is rather a robust sector within the economy. It contributes 2% of the gross value value and employs 4.6 million people. As of now, when you take countries in focus, France, Italy, Germany, and Spain are some of the largest producers by turnover. Within the food and beverage industries, if you look at the sector, you would see that the food and beverage industry is split into the small and medium-sized enterprises and the large companies. Now, this data set is only for the European Union and has been provided by Data and Trends of the EU food and drink industry. Over here, you can see in terms of turnover, the large companies have a turnover of close to 60%, and value addition also close to about 60%. However, the number of persons employed is higher in small and medium-sized enterprises, or so-called the SMEs, and the number of total companies that are there are higher by 99.2%. So there are a large number of SMEs in the European food and beverage industry. And therefore, when we think about optimization, it is very crucial that this optimization in the food processing sector is in energy as well as cost efficient that will allow SMEs to implement it. And why do I say that? Is because SMEs tend to have a lower amount of capital. They do not have that much of flexibility, and therefore we need to find solutions that are easily adaptable as well as energy efficient and cost efficient. This means that when we look at the current challenge that we have in the food industry is as follows. So currently we have a raw material coming in, and this is usually from the farm. It goes into storage, goes through preparation, processing, packaging, and then comes out as a final product. Of course, you have energy, water, and the several byproducts that are coming out. So you have core and byproducts, waste heat, solid waste, and wastewater. Yes, this looks like a linear economy. And I'm not saying that completely the food processing industry is a linear economy. Most of it is shifting towards more of a circular economy where most of the byproducts are used in one or the other form. However, there are certain sections that still have a linear economy because they do not have the flexibility or the investment to change from it, to change from the linear economy to a circular one. Another issue is the black box. In the food processing industry, what usually is important is the final product. And to that end, what is the next important bit is the raw material. And everything that happens in the process, it is not usually looked into. It is not analyzed, or the changes that happen during the process are also not considered. This is difficult because you cannot optimize a process if you don't know what is going within it. This means we need to open this box. And by opening this box, it means that we need to look into the energy factor, the economics, of course, the sustainability factors, the quality of the product, and as well as the data that we acquire from actually opening this box and ensuring for a better process optimization. So, to take it from a linear to a circular economy, it has different and significant level of steps. So as we all know, a linear economy, we have make, use, and throw, and we want to move it towards reduce, recycle, and reuse. However, we just don't want to move from a linear economy to a circular economy, but rather to a circular bioeconomy. Now, bioeconomy is also not a concept that is very new to all of us. This term has been there for quite a lot of years. Looking into literature, there are more than 200 definitions of bioeconomy, but one of the most used bioeconomy definition is the one that was defined by the EU Commission in 2018. And that definition says that bioeconomy, of course, covers all sectors and systems that rely on biological resources, their functions and principles. It includes the land and marine ecosystems, all primary production sectors that use these biological resources, and all the economic and industrial sector for biological resources and process to produce food, feed, bio-based products, and energy services. So yes, it's an extensive definition, but it does cover everything that is required for us to build a sustainable circular bioeconomy. The food industry, for that matter, has been contributing quite significantly to this bioeconomy. And these numbers are based on the EU bioeconomy. So almost half of the overall turnover of the EU bioeconomy comes from the food and drink industry. And more than a quarter of the total employed are from actually the food and drink industry. And what is quite evident from the data and the trends is that there is a constant increase in the overall contribution that the food and drink industry is giving to the bioeconomy. Now, as we talk about food and drink industry, I would like to give you an example of the food drying process. You may ask why the food drying process, or why especially the drying process in the food processing chain. So drying is very close to my heart. I have been investigating it for several years. So it's something that I have known for quite a lot of time now. As you know, a drying process is a unit process, and in the food processing sector, it has been implemented at some or the other point. Not all processing lines or all processing sectors implement the drying process, but more than often, you need a drying process to either further process one product or in order to increase its shelf life. There are different drying techniques available, and they can be implemented depending upon what the final product is required or what the raw material is coming. Why dry a product? And that is because it helps you package easy, so you have less cost of transportation, and it is also efficient sometimes. Now, in the drying process, what do we want at the end? In the drying process, we want high quality product that can come to the market and has high nutrition quality, as well as it is consumer acceptable. It is energy as well as product efficient, because we all know that drying is an energy intensive process. We want dynamic process optimization. That means that the system learns and optimizes. And as we are considering this unit process, we need circularity even within one drying process. However, we have a challenge, and the challenge is that in the drying process or in the food processing sector, there are heterogeneous products like fruits and vegetables that have a significantly high influencing parameters. And these influencing parameters also affect the way you optimize a drying process. As of now, the parameters are defined at the start, a product is included, and then you have a final product. But if one specific product does not fit within the range of acceptability, it is rejected. And if that is rejected, it goes as a part of food waste. Food waste is something that we want to reduce so that we can help in the sustainable development goals. This also means that it has inefficient process settings, because one process setting is applied to the process for the rest of the time. This means you might have 50 degrees or 60 degrees applied for more than 2 to 3 hours without any consideration of the changes that are happening within the product. So, what could be the solution? Well, the solution is that we take a quality by design approach. Now, a quality by design approach is also something that has been there around, but I am now specifically using it for the drying process. You might say that I have written quality by design traditional. Traditional does not mean that it is too old. It's just that we have come along to new technologies, and I will show you what is also a modern quality by design. So let's first start with the quality by design traditional. In this section, what is very important is that we always take the product as the first criteria. So that means all the critical quality attributes that we require in our final product are set first in the product performance stage. Once these criteria are set, we then move towards the product and the process design space, where the process parameters of the incoming fresh produce that is coming in is set. Now, these two sections need to be controlled in a much specific manner, and to that end, you have the process performance stage where you have a control strategy. The control strategy helps to make sure that the quality attributes that you have first set are achieved, and the process parameters are then also adapted to these quality attributes. Now, this is your traditional quality by design. When you move to a modern quality by design, you have a small change where you have the inclusion of a model. So let me process once again this with you. You first set your attributes in the product design space. So you start with the right hand side, so on the yellow side, where you identify the quality attributes you want for your final product. You then move on to the parameters that you want to set in the process design space. Set all of this in the green space. You have the controller that is managing both the product and the process design space. But in addition to that, you have models, or so called as the model references, that are there, that are working behind together, learning the system, taking in all the data that it is getting in real time, and inputting it into the controller to adapt the system based on the information that it is continuously getting. These models rather simulate more real behavior and help us optimize the process. With the current developments that we can have different types of models. In the drawing process, we've had simplistic models that have been able to be integrated into a control strategy. But simplistic models do not simulate real behavior. They take into consideration a lot of assumptions, something that does not help in optimizing in an efficient manner. So, new systems like intelligence, so models like machine learning models, help us understand the complexity that is there in the drawing process. The drawing process might seem quite simple at the beginning, but the more in depth it goes, the more critical it becomes that each and every variable is included into a model, that it can really mimic the changes that are happening within the product during this process. And machine learning models can actually also help facilitate the control of this process. Another good thing is that because we have trained these models in such a way by giving in real time data, they can imitate human intelligence and allow us to optimize our process in a much easier manner. Currently, machine learning models that have been implemented within the drawing process are used to determine, for example, transport properties and mechanical properties. But we are currently working in to extend these to have further properties of a product to be modeled using machine learning techniques. Another technique that is there is digital twins. Now, digital twins is also something that is known in the system where it mimics like an actual twin. So you have the real and the digital twin. It is cost effective because as of now, everything is experimental based or completely theoretical based. There is no midpoint to it. And to that end, when it is experimental, it is not cost effective because we have to do a large amount of experiments to create a foundational database. The digital twin helps us reduce that. It can help predict problems because you have an actual twin, a digital twin that can tell you how your real system might behave based on previous behaviors. You have accessibility to the data set, waste reduction because you don't have to do as many sets of trial and errors. And at the end, a digital twin also requires a foundational database, so you have a significant amount of documentation and communication. We've already implemented the first digital twin, and as you can see, we have a paper published which is called a hybrid digital shadow that assesses biological variability in carrot slices during drying. And one of the main conclusions is that when you have well defined boundary conditions in your model, it helps you reproduce the real behavior for your twin. It also represents the complex drawing process. So the digital shadow that has been developed over here allows represent the complex drawing process. And because we can reproduce and represent this complexity, it can eventually help us even optimize the overall food supply chain because we can actually include which raw material is coming in and how do we want it starting from when it comes from farm all the way when it goes to the end as a final product. So to give us outlook in the food processing sector and how do we want to move ahead in it is that for an holistic optimization, we need to look from a farm to fork approach. Like I said, models such as digital twins or artificial intelligence models have the capability to collect the data set, simulate models, and allow to develop a more farm to fork approach. It is also very important that we have integration of sensor technologies because that helps in real-time control of our product quality. And at the end, we can also have a process and a product optimization that will help us build a sustainable food system. And now, finally, when you look at the outlook that we have for the food processing and take it at a much higher level as to the circular bioeconomy, what do we need next to have this processing the way towards circular bioeconomy is that we need to have far more open communications for policies across multitudes of levels and ask for furthermore standardization. We also need to have a stronger database that can allow for continuous process optimization. And I'm not calling that for food or for any specific sector, but a stronger database from which we can learn. Of course, the integration of new technologies, because we do have many small and medium sized enterprises that require cost and energy efficient technologies that they are able to invest into. And at the end, we also need education to our future generation on the topic of circular bioeconomies to take the step forward. As it is often said in the CBSI as well, is that we need to take a system of systems approach to the circular bioeconomy topic so that we can help in developing it much better. And as we all know, and as we all resound every time, is that we need to work together towards having a much more sustainable circular bioeconomy. Thank you so much for listening. I would like to also acknowledge the Leibniz Institute of Agricultural Engineering and Bioeconomy, as well as the Humboldt University and EMPA for the current work that has been conducted in the development of digital twin, as well as the joint lab of the Leibniz Institute of Agricultural Engineering and University of Osnabrück for the artificial intelligence in the drying process.
Great. Thank you. All right. So with that, I will open it up. If there are any questions from the group, feel free to unmute and ask, or if you feel more comfortable typing it into the chat, we can read it out here. I'm not seeing anything in the chat yet. We'll see.
So this is Brown Burma. Can you hear me?
Yes, we can.
So what I like to hear from you is that the byproducts that you show that are now coming out from the system, what kinds of alternative uses have you been able to find? Such as you had a slide where you're showing the inputs and output of materials. Have you found some alternative use other than just disposing them off? And what are some of the concepts that you have?
That's a really good question. And that is something that we are also struggling right now. If you have to take, for example, a fruit or a vegetable, we are currently looking into, let's say, carrots. The research that we are conducting right now is very specific to know how we can optimize the process. So now, slowly, as we are moving towards the circular bioeconomy, we are looking into byproducts. So for example, sometimes we have to peel our products before they actually go into our process. And we can look into alternative uses for the peel, but it's still under investigation. So how can the peel be used? We're looking into it.
Yeah. So it's a very, very nice presentation. But I think most of your work currently is focused on efficient use of input resources. You've yet to look into the perhaps reuse of your materials yet. Will that be a correct interpretation? Yeah. Okay.
Yeah.
Thank you very much. Very nice work.
We've had a couple of questions pop up in the chat. First one is, perhaps you defined it, but what do you mean by turnover in this presentation? Is it turnover of people and employees or something else?
Turnover, I'm just quickly going back, making sure that I mentioned, so overall turnover in terms of monetary terms or turnover when it comes to it.
Okay. Sorry, the questions are popping around. They're coming in quickly now. It says, great presentation. In the application of AI in digital twin development, were you able to integrate established engineering relationships? So for a simple example, if the flow rate of dry air is increased, the product drying rate will increase.
Yes. So in our current work that we are doing, we have been integrating that, and we have been looking at all the influencing parameters and the variables that are there. This also means that even smaller things as the heat and mass transfers that you have between the tray contract, because we are looking into a batch process as of now, and when we are looking at a batch process, we are looking into these sections and trying to establish relationships between them. I cannot go a lot more detailed into it. It's a part of my doctoral students' work as well, so I need to give that paper a chance to get published first, and then give a chance for it to go ahead. Yeah.
We had a couple come in about digital twins. So I'm just going to lump these two together. So first is a digital twin, a computer simulation model. And can you elaborate on how you construct a digital twin? What does it look like? What is involved? What data is required?
Okay, so two things. It's not just completely a computer simulation model. Yes, it is a computer simulation model, but there is a lot of factors involved into it. When you come at the section of how do you construct it for a digital twin, it takes time, of course, but more than that, when you ask what does the data look like? So we had real-time data from experimental analysis that we had done. That is why the emphasis that we need very crucial foundational database, because without that database, there is no possibility of constructing even a model or a twin for that matter. So a real-time data that was developed through my work, for example, was then the foundational database that we took for the model to learn through. This is not previously done by other models because they take assumptions, they don't take real-time data. We take data that was from actual experiments and try to see the changes and simulate them. We need a lot more data. We are only scratching the surface. We are not we do not have an extensive database. That is why we always say that the more the database, the better it is. Because it helps us learn a lot more, but we have only scratched the surface for that matter.
Okay. We have another one here. Have you considered integrating LCA?
That's a good question. No, we haven't as of now, but that's a good point, and I will take it ahead.
Okay, and I think this one kind of goes along with it, and it's whenever you're thinking about the whole system. So are there any concerns about the energy used by the computer systems that generate AI systems, or similarly, in the addition of computer systems that could add digital vulnerability to food systems due to malicious hacking?
Once again, actually a very, very, very good question, and a very eminent question at current time, saying that how much hacking is taking place. I have to be very honest, malicious hacking was not something that I had taken as in my mind as well, but I am going to take that back. As in terms of concerns of energy, we have been looking at energy in terms of our process of the computer systems, not exactly right now, but that is a good point. When we are doing, as of now, as even Ram mentioned, we're really focusing because on getting our process optimized, our process in itself. When I say about our process, that means the drying process and the convective drying process, to be very specific. It was inefficient, and we are right now optimizing it to a level that we can get at least the first line done, and then move towards getting it a little bit more towards circularity. So yes, that is actually two good points, LCA as well as hacking and energy calculations into.
These are very complex systems.
Yes.
All right. Okay, I think there's a lot of interest in digital twins. We got another digital twin question for you. Is your digital twin model basically a multi-physics, meaning heat and mass transfer model with real-time data tightly integrated during iterations?
That's true. Yes. It's a hybrid-based, a physics-based hybrid digital model as of now. We do not call it a digital twin. That's why we call it a digital shadow. We believe we have our definitions because there are, just like bioeconomy, there are more than 100 definitions of a digital twin when you go out there, but we have split them into what actually looks as a digital model, a digital shadow, and a digital twin. We are not at the digital twin state. We are at digital shadow because we're using a hybrid physics-based model. And as you explained, yes, with iterations as of now. Yeah.
All right, great, thank you. No more questions or comments as of yet. Oh, wait, sorry. Just as I was saying that. Who would benefit the most, SMEs or large industry, by the use of digital twins and models? And thank you.
Futuristically, SMEs, yes, because it would be an easy implementable system based on data that we have learned. So it is, they would not have to invest in so many of sensor technologies, and it can help it. But this is something that a trend will tell us whether it would be. But we are aiming that we want to support SMEs.
And I think this may have just answered this question, but just in case there's anything else you want to add to it, how is your work applicable to small operations?
As of now, we're making process optimizations that can be directly integrated. So based on information that we have for small operations, we give them insights that can allow them to have high quality product without changing the system significantly. And that is why we are doing it for small operations, small systems, and that's how we built it up slowly up to medium enterprises.
Okay. And again, I think you've sort of already touched on this, but maybe just a clarification or a follow-up. What is the difference between a digital shadow and a digital twin model?
Yeah. So it comes back to different sets of definitions again that it goes. I'm still a guest researcher, but I was a researcher at the Leibniz Institute of Agricultural Engineering and Bioeconomy. And that's where we defined three sets for us that we understand. We always say we ask also what others understand as digital shadow and twin. There is always controversy over there. But for us, we say a digital shadow is something that it has taken in the data set, it is learning from it, and we are feeding it. Digital twin is when it has complete autonomy. It is completely autonomous. We are not doing anything into it. That is when a digital twin has been developed for us.
Great. From where does the quality model come from?
So the quality by design, I believe. So the quality by design was developed by one of the researchers that has worked into one of our projects, where we saw that the product quality is the far more important aspect and then taken into consideration as we come into process. So for me, that it started on there, but quality by design as an approach has been used in different industries on different levels in different manners previously.
All right. One final question that I have is in your outlook or in your on the kind of on the horizon kind of things, you mentioned that there's a need for education. Can you maybe touch on that a little bit more? What do you see as being needed in that area?
So, as somebody who works on the young professionals side, something that we know or we realize is that it is very important from graduate level that people know what is circularity. Students know what is circularity, what is circular bioeconomy, because it plays a significant role for them to understand when they go ahead. As of now, even when we talk about circularity or circular bioeconomy, there are many questions as to how each of us understand towards it. And if we have to develop, then it would be nice to develop a curriculum that really focuses on circular bioeconomy and focuses on this topic that would help not just future generations, but for our understanding as well as to how we need to develop.
Okay. All right. I think that may have inspired a couple more questions. Is quality by design similar to quality function deployment developed in Japan in the 1950s?
Good question. I would have to go back to it. I would be very honest with it, but I will write that up and I will research on it.
And then for new graduate students, so maybe thinking more of the educational side again, what is good software platform to develop digital shadow twin models?
So COMSOL is one of the good starting ones that you can do with. And you can look into it. You can always go back to our papers as well. We have a lot more information of how we have developed it, and you can also get in touch with us.
All right. Well, great. Thank you very much. Let's thank our speaker again. I'm not seeing any other comments at this moment. All right, we'll give it just a minute. We got some thumbs up and applause out in the audience. Thank you.
Thank you so much for having me.
Yep, absolutely. So I want to thank you all again for your participation today, and I want to give a special thanks to our speaker, Dr. Sharvari Raut, my co-moderator and ASABE Director of Membership, Sarah Rodriguez, and everyone else who contributed to making this member hour possible. Our next webinar in the CBSI series is scheduled for Thursday, May 23rd at 1 p.m. Eastern. We will have Dr. Anurag Mandalika from the Center of Energy Studies at Louisiana State University discussing opportunities for energy and industrial decarbonization in Louisiana using agricultural and forestry residues in this transition. And as a reminder, all these sessions in the series will be available on YouTube via the ASABE and CBSI websites. And if you're eager to connect with others and advance the circular bioeconomy systems movement, mark your calendars for the 2024 CBS Day event in Anaheim, California on July 28th. You can head to ASABE's meeting registration page at www.asabemeetings.org for more details. You can also follow the Circular Bioeconomy Systems Institute group on LinkedIn. A link for that group has been added to the chat. And once again, thank you all for your valuable time and engagement today, and we're excited to be hosting you again at future ASABE events. Thank you very much.